Guys, in today's video we're going to be looking at composite functions. This is an extremely common topic in the AHL exam. Before we get into it, I have to go over a couple bits of notation that we have to know. So if we have a function of x in this format, so let's say we have f plus 3. This basically just means function f, this colon looking symbol is such that, and this is just x, and then this arrow is converted into, and this is the function that is being converted into 2x plus 3. So this form is equivalent to saying f of x is equal to 2x plus 3. You should all be familiar with this and how to manipulate this. And for example, let's say we have f of 3, this would just be 6 plus 3 equal to 9, right? And this is also equivalent to y is equal to 2x plus 3, where f of x is the value given value of y for a given value of x. So y is equal to f of x. And it can be stated that x is the independent variable and y is the dependent variable. Alright, so now let's get into it. So we can, to show a composite function, we could have two functions, f, let's write in blue, f, so f function of f such that x is converted into, so f such that x is converted into f of x, so this is just a function that's being converted into. Let's say we have g of x, so g such that x is converted into g of x. So let's just say we're going to make a composite function of both f and g. What will this look like? So a composite function of both f and g will convert x into f g of x. So instead of f such that x is converted into f of x and g such that x is converted to g of x, we actually get that the function of both will convert x into this. The notation we use to represent composite functions is this. It looks like an O, but this actually just means f following g. So this represents the composite function of f and g, meaning f following g. So f following g of x is equal to f g of x, and or this can be expressed as f following g such that x is converted into f g of x. You guys should be familiar with these functions. This just means that the function of g of x is inside of the function of f of x. So therefore the function of f is g of x. So let's do an example if you don't understand. So let's say we have f such that x is converted to 2x plus 1 and g such that x is converted into 3 minus 4x. You can rewrite them if you're not comfortable with this form. It's just f of x is equal to 2x plus 1 and g of x is equal to g of x is equal to 3 minus 4x. Righty. So if we're asked to find, let's say we have an example question where it says find f of following g of x. How would we do this? Well, we know that f following g of x, this just means that f is following the function of g of x. So it's, in this case, it would be f following g of x. It's literally what it's saying, you just write. So f following g of x. So g of x is happening first and it's inside the function of f. So what does this mean? So what's the function of g of x? 3 minus 4x. We substitute it in, as g of x is 3 minus 4x, we can substitute it in here, so we get f of 3 minus 4x. And we have f of x is equal to 2x plus 1. So what does this mean, f of 3 minus 4x? So when we have a function like this, the numbers inside the bracket, or the expression in the brackets, will replace the x here, so it will replace the x. Therefore, we are left with 2 is equal, that f following g of x is equal to, substituting this expression into f of x, we get 2 times by 3 minus 4x. I've just substituted it in the place of x, as it's now the new function of x. So we have plus 1, where we will get 6 minus 8x plus 1, and we get 7 minus 8x. Now, let's say we have another question. It's asking you to find g following f of x. And what would this be? Well, g following f of x, so the function of f of x is replacing g of x. So we have g following f of x. And therefore, what's the function of f of x? That's 2x plus 1, so we can substitute that in as 2x plus 1. And what's the function of g of x? Well, g of x is 3 minus 4x. Well, now the function of x is this, so therefore we substitute this for x, and we get 3 minus 4 times by 2x plus 1, 3 minus 8x minus 4, leaving us with minus 8x minus 1. So therefore it can be stated, in general, f following g of x is not equal to g following f of x. Alright, let's try another example. Now, let's say that we're given f of x is equal to 6x minus 5, and g of x is equal to x squared plus x. And we're asked to find g of f minus 1. So what is this actually asking us to do? This is asking us to find g following f minus 1. G following f minus 1. So how can we do this? Well, it helps to break this up into smaller segments. So this is our inside function. It'll be helpful to get an expression for our inside function, which we can do just by substituting minus 1 in for x, whereby the function of x is now minus 1, so therefore we can substitute minus 1 right into there. So we get minus 6 minus 5, minus 6 minus 5, that will just grant you negative 11. So therefore this can now be rewritten as g of negative 11. Now, how do we do this? Well, we know g of x is equal to x squared plus x, and now the function of x is now negative 11, so we can just substitute it into here for x. So we actually get, so this is equal to negative 11 squared plus 11 plus minus 11, so we get 110. So now we have f following f of 0. This is equal to f following f of 0. So our function f of x is 6x plus 5. So, but now the function of x is now 0, so we can substitute 0 in for x, and we get 6 times by 0 plus 5. So we have f, and what is this? This is just 5, so we have f of 5. What's f of 5? Well, we know f of x is equal to 6x plus 5, but now the function of x is now 5, therefore we can substitute 5 into here, and we get 6 times by 5 plus 5, and then we get, oh sorry, this is meant to be negative 5, this is meant to be negative 5, minus 5, minus 5, this doesn't change the question, this would just mean f of negative 5, and then we can substitute f minus 5 in, so we get negative 35. Alright, let's look at another set of examples. These look kind of, okay, yep, this looks like a good one. So let's say we have functions f of x is equal to 3 minus x squared, and function g of x equal to 2x plus 4. Let's say we're trying to find in the simplest form g following g of a half. How would we do this? I'll give you guys a couple of seconds just to pause the video and have a go yourself. If you can't do it yet, then that's okay, because I'll be running through it in a bit. Right, so giving you enough time. So let's say, so we are doing g, this means g following g of x, of a half actually, because it's not x here, it's a half, so therefore we put a half there. So what is actually g of a half? Well, g of x is 2x plus 4, therefore now the function of x is now a half, so we can substitute in here to get 2 times by a half plus 4. We just get 1 plus 4. 1 plus 4, I mean. And that's just going to be 5. So g of a half is equal to 5. Therefore, we can substitute this back into here. And then this becomes g of 5. As g of a half is equal to 5, we instead of using g of a half, we can just use 5. So g of 5, what's that? That's 2 times by 5 plus 4. Because the function of g of x is equal to 2x plus 4. Therefore, substituting 5 in, this is what we get. So we get g of 5 is equal to 10 plus 4, which is equal to 14. Therefore, g following g of a half is equal to 14. Nicely done. Alright, let's try this for f following f of negative half. Alright, so here let's say that f of x is equal to 3 minus x squared. I'll give you guys a couple of seconds to pause the video and have a go. Alright, so how will we do this? Well, we know f following f of negative half will just literally just be f, where the inside function is f negative half. And we have the function of f of x, so we can just substitute this into here. Well, the function of x is now negative a half, so we can replace x with negative a half, leaving us with 3 minus negative a half squared, which, what does that leave us with? Well, that leaves us with 3 minus a half squared, which if you do simplify will leave you with f of 11 over 4. If you don't know what I've just done, I've literally just multiplied negative half by negative a half, and then converted it so that 3 is over 4 as well, and then yeah, that's how you do it. So, because if you don't know, a half times negative a half will be positive 1 over 4, but now we're doing 3 minus positive over 4, we know a negative plus a positive is a negative, so 3 minus a quarter. Converting 3 to be over 4, we just times it by 4, so we get 12 over 4 minus 1 over 4 is equal to 11 over 4. That's how I obtained 11 over 4. So actually, that's how I obtained 11 over 4. So actually, we actually have f 11 over 4 because 11 over 4 is equal to this, so they're interchangeable. Therefore, now substituting 11 over 4 into our original f expression, we get 3 minus 11 over 4 squared. So what would that leave us with? That will leave us with negative 16. Negative 20, negative 73 over 16. That would be your final answer. Alright, let's run through a couple more. Try to look at some harder ones. So let's say that we have functions f of x is equal to 1 minus 2x, and we have function g of x is equal to 3x, let's say plus 5. G of x is equal to 3x plus 5. Now, we are going to be asked to find f of g of x. So f of g of x. What does this look like? Well, what's g of x? 3x plus 5. So g of x is 3x plus 5, and we have g of x in this expression. So actually, we can change this g of x into a 3x plus 5. So f of 3x plus 5. Now, what do we do now? Well, we have our function for f, where f is, so f of x is equal to 1 minus 2x. Well, we don't have f of x, we have f of 3x plus 5. So what would this be equal to? Well, we can, instead the function of x is no longer just x, it's now, the function of x is now 3x plus 5. So we can substitute 3x plus 5 into here. And what do we get? We get 1 minus 2 times by 3x plus 5. So we get 1 minus 6x minus 10. And then we have negative 6x minus 9. And that being our final solution. Now, let's say it says, there's part 2 to this question. It says, hence solve f following g of x is equal to f of x plus 3. Well, what would this mean? So let's say, so f following g of x. So we've just worked out f of g of x, which we found to be negative 6 minus 9. And we also have f of x and g of x, where f of x is previously stated as minus 2x, and g of x is equal to 3x plus 5. And if you haven't noticed already, this is the same as saying f following g of x. And if you look in the question, we have f following g of x is equal to f of x plus 3. So what we can do, therefore, is substitute f following g of x with f of g of x, and then solve for x. So how can we do this? Well, f following g of x is equal to f following. Therefore, and we already know this to be negative 6x minus 9. And then, well, what's f of x plus 3? Well, f of x we have as, and we need to find f of x plus 3. Well, the function of x isn't just x anymore, it's now x plus 3. So we can substitute this in the place of x to get 1 minus 2 times by x plus 3, which we get 1 minus 2x minus 6. Minus 6 plus 1 minus 5 minus 2x. So this is equal to minus 5 minus 5 minus 2x. Now we can add 2 to the negative 6x, we get negative 4x. We can just put this over to this side, changing the sign, of course. and this is equal to negative 5 plus 9, which will just be 4. Now solving for x, we get x is equal to negative 1. And there we go. Now let's say that we have a pair of functions and we have to state its domain and range. This is a very common question to come up. It's usually just a little, like a few marks typically. So let's say that we have this question. So for each pair of functions, for each pair of functions, find f following g of x, so f following g of x, and state its domain and range. And range. So let's say f of x is equal to 1 over x, and g of x equal to x minus 3. Alright, I'll give you guys a couple seconds to pause the video and have a go. Okay, so we know that f following g of x is equivalent to writing f of g of x. But what is g of x in this case? Well, g of x is just x minus 3. Therefore, we can substitute g of x with the expression of x minus 3. So we get f of x minus 3. Right, equal instead of equivalent, but they are equivalent both, but we are setting up an equation. So now, what's the function of x minus 3? Well, the function of x is equal to 1 over x. So the function of x is now x minus 3. Therefore, the function of x is now x minus 3. So instead of x here, we have x minus 3. So we have 1 over x minus 3. So therefore, the function of x minus 3 is equal to 1 over x minus 3. So f following g of x, or f of g of x, is equal to 1 over x minus 3. So what would be the domain of this function? The domain is just a set of values that x has to be within. So what can x not be? So, well, x cannot be equal to 3 because then the function will be undefined. So therefore the domain is x cannot be equal to 3. Well, why can't it be equal to 3? Well, when x is 3, we get 1 over 0, which is undefined. And therefore will leave you with an error if you try to input it into your calculator. And what would the range therefore be? Well, y cannot be equal to 0. Well, because 1 over any number will never equal 0. Because to obtain, so the way it works is, well, 1 divided by any number would give you that number. Well, but if 1, to get 0, following this logic, we'd have to divide it by 0, which we know will leave us with something that's undefined. So the domain and range is a set of values that, or a set of rules that the x and the y values have to abide by. So the domain of this is x such that x cannot be equal to 3. So it can take any value, but it can never be equal to 3. And the range is y such that y cannot be equal to 0. Alright, that'll be it for this video. Thank you guys for watching. Make sure to like and subscribe. Thank you.